Good morning, everyone. My name is Yuri and we're gonna live code some WebGL animation today. Let me know if you can hear me well and let's get started. Hopefully everything is all right. And while my video gets to you, because we have some delay, not when I'm saying you see it, maybe in 30 seconds. I have a Patreon. If you want to support me, you can go to the patreon.com all your HTML. Not much you get in return. I just posted the Three.js boilerplate in there, but maybe I will post something else too. Morning, everyone. It'd be nice if you share like where you're from. I have a lot of people from Russia today. Доброе утро. Доброго ранку. Yeah, so let's get started. I hope it's gonna be a simple stream today, finally a simple one, because we sort of did parts of this today's animation in one of the previous streams, but I had some nice insights while I was decompiling this one, and I think I'd like to share it with you. And it's one of those hard mornings, you know, so I guess it's good that it's gonna be a simple animation. Croatia. Hey. Nice. Okay, I'm gonna switch the screen. Perfect. So it's gonna be this website. Maybe it's not the most complicated tech, but it kind of get this I don't know, it's just cool. It's just cool that the video then transforms into particles, and then particles transform into something bright, and then back into the video, and it's just cool. Hey, Poland, Baku. Nice. All right, so let's get started with this animation. I'm gonna start with my Three.js template this time. I'm gonna call this one trust. And by the way, just to give credits to all the developers, this site is done by the agency called Lig. Yeah. Oh, morning to Zagreb and France too. So this website done by the Lig agency. I actually really like all the Japanese developers scene. I think they're a bit disconnected from the European dev scene. There are some connections, but they're not really integrated yet. And there are some cool websites, some really cool new effects that none of the Europeans may be using. I haven't seen at least some new approaches and all that stuff. You know, I really respect Japanese as a craftsman. They are really good at being good at something, being best at something. So yeah, I advise you to check out their websites. Some of them are really cool. I mean, in WebGL way, some of them just cool design. And we're gonna be decompiling their website today. Okay, so it's mtrust. Mtrust it is. I'm gonna copy paste my template. I'm gonna open it up. Oof. Norway. Oh. Hello to Norway. I wish I would travel to Bergen again. Boom, boom, after this whole pandemic ends. Alright, so now we should have something, yeah. We have the UVs, we have the plane, we have the boring part. We could do the layout now, just so see as much as possible. Hey, morning everyone. I kind of need to do this layout thing so I could see the chat and all the stuff on the same screen, at least the last message. And then we have the simple HTML. I'm gonna just run through the code that we already have, and then the simplest possible Three.js boilerplate file, where I just have two shaders, fragment and vertex, and then I'm seeing them on a screen. And I finally updated this part with orbit control, so it's now not a separate package, but it's getting from the examples. I should have done that maybe 2 years ago. Okay. So yeah, hello to Russia too. So yeah, where do we start with this? So first of all, like, how do I do those decompilations? First of all, the best way to go to the network tab and then just see what are the resources they're using. And surprisingly, it's not just the video. Of course, there's some videos. There's gotta be some videos. Yes, the file names are weird, and that's why I'm not seeing them yet. Okay, it's video 2, video 3, and probably somewhere video 1. Okay, I'm gonna just open the new tab. So these are the videos that they're using. They're really like iPhone-like, and I bet on the iPhone you're just gonna see the full screen video. Anyway, I'm gonna save it. I'm gonna save it to mtrust folder, like the one MP4, and then maybe another one for science, 2 MP4. Now we get them. Surprisingly though, it's not just the videos. They actually have the first and the last frame of each video, and this kind of cuts to the core, but let's see if we can maybe avoid using this, or at least optimize it in some way. No, it's not carousel Three.js. Well, everything is carousel. Like if it's changing, it's carousel, I guess, but it's just some simple particle effect. So let's get started with particles. First of all, if you remember one of my streams where I was decompiling the website by Matthias Biaviani with all the particles and stuff, like this one. I'm not posting a lot, so it's gotta be close. Yeah, like this stream, but I did a lot of particles and I used an image on them, so it's kind of gotta be like that maybe, but not quite. And I started this development like with the same approach, but then I decided that I actually know better now. I actually know better. So first of all, I'm gonna use the particles. I have the particle shader here, vertex particles. I did this shader from scratch in that stream. Anyhow, the only difference here is that we have the GL point size where we size the particles, and I guess it's too big. So now, instead of using the plain buffer geometry, which I'm using right now, I don't need all of this actually. This is redundant. So instead of using plain geometry, I mean, we could actually use plain geometry, but instead of using the mesh, we could use points, just like that. And we gotta see something new. Yeah, so it's 4 points because it was plain 1 by 1. And just the same way we could do this. So it's a lot of particles now, and maybe even smaller ones. So this way we could just do a grid of particles. I think it's the simplest way to do this, but we could do more. And by the way, why is it a grid of particles? If we just switch to mesh and then wireframe true, it's those vertices. Yeah, so it's just the geometry. We have those particles, right? And I think this is the first insight that I had. Well, I might have used this approach instead of just calculating each particle position in my loop. So I might have just used plain buffer geometry. And I think guys at the website, they also calculate in each particle position in the loop. But I think it's actually not needed. It's not needed. I think plain buffer geometry would work a bit faster than the plain geometry. So the website is gonna load faster. Okay, so now we have this. Let's check this shader is working. Red is probably not the best choice. Yeah, it's yellow. It's even the worst choice, but you can still see them. Okay, next thing. I want to do as many particles as I have pixels on my video. And the video is 180 and 820. And this means that I could just do 180, 180 it was, right? Yeah, 80. So I could just do this, and it's gonna be one by one, but I'm gonna have lots of particles now. And I don't need it to be one by one because I need to preserve the aspect ratio, so I can do it's this number, and then I could multiply one. I could just do this, sort of this. So it's approximately the aspect ratio of my video now, and everything seems correct. Just to preserve the number in system, and I think it's more obvious. Plain buffer geometry and plain geometry. Plain buffer geometry, I think, is simpler, and it just stores all the positions in the attributes array, and then the plain geometry, we could actually do this just to approach. And the plain geometry, I think, gotta be deprecated at some point, and it stores in some vertices array, and sometimes it's useful to play with the vertices that way. We could just see the difference here. In the plain buffer geometry we have attributes and then position, and in plain geometry we don't have actually attributes, but we have faces, face vertex UVs, and then we have vertices where we have an array of the vector 3s instead of just the typed array in the positions, like this. Come on, I gotta get deeper, like this. So it's just the matter of structure, and I think the plain buffer geometry should be initialized faster than the plain geometry. So anyway, I think it's better always to use plain buffer geometry, all the buffer geometries, if you're not playing with the inside of the objects. Hello to Denmark too, and India. Oh my god, we have a huge geography today. I believe all the Americans are celebrating, so I mean half of them. Okay. What's next? So yeah, we have points. I wanted to change the sizing a bit. Let's make it a bit bigger. I think it's easier to my mind to handle the numbers like 1 and 1000 instead of 1,000th of 1. Like, it's just a bit easier to operate with the natural numbers. And then I want to put the camera real far away, and then well, thank you for your support. Okay, not doing a great work yet. I'm kind of slow thinker today. It's just slow thinker. Yeah, I wanted to change the sizing, so I put my camera away from the particles. Now I believe I will need to make my particles a lot bigger for everything to work. So camera position is far away. Now when I save the object, I wouldn't be able to see anything, just maybe some small yellow dot. Then I would need to maybe just convert those to pixels. So instead of this, I'm gonna just write the natural numbers. And that approximately gives me the same result. But now we operate with the just the usual numbers, like the pixel numbers of the object. And then could make it even bigger. Maybe I'll just multiply this by 1.5. Yeah, like that. Now the particles I think are a bit too small, so I'm gonna just do the fixed size. I don't actually need any perspective, so I could just do the pixel size. And I believe double is just 2. I mean, it's just the pixel size, or not? I think when we look from far away, even though they are small, it still paints it all yellow because of anti-aliasing probably, or something like that. And maybe I shouldn't be using the yellow anymore because I can't see shit on my screen. Yeah, red ones at least are visible. So yeah, it's somewhat like a grid of particles. They're far away and they form an image because they are kind of pixel assigned to each of the particles. So then I have this inside. Because I've been decompiling the code, like really reading the code, the minified code and all the stuff, I do this. Yeah, I found out that the guys to convert, well, what I'm trying to do, I'm trying to paint an image now. So last time, in the last stream, we painted an image with the shader. We just, we had a texture and we used the texture to paint all those particles. At this particular website, they using the Canvas 2D, so they first drawing this image, like I mean static image, the ones that they have here, like these ones. They're first drawing them to Canvas, then converting them to the attribute array. So they're actually getting pick color of each pixel on this image, and then converting that to the attributes array, and then assigning that to the shader. Well, that of course works obviously because we see this cool website. I'm not sure the reason why would they do that. Probably maybe some experiments led them to this, maybe, and this is just a leftover code, or maybe there's some benefit in this. I don't know, maybe you know. So they're not using this texture as a texture, but they're essentially converting this texture manually on CPU to the attribute array. Anyway, so I'm gonna probably cut the corner here and just use it as a texture. Lot T. All right, and then I need to have this texture in the first place, right? So I downloaded those two videos, like one of the videos was with a white flower and then this one, okay. White flower, okay. We have this. Okay, it's good, it's good. And then we have texture now. Yeah, but they're not really getting frame of compressed video, but like they're pre-saved frame. Well, I don't know, maybe I just didn't get your point. Okay. Anyhow, I'm gonna try to use texture, and this is one of the insights that I had, like maybe you could do it easier. So sometimes when I dig the animation now, I'm just realizing, well, we could do this thing actually easier and better, because I already had like 10 animations, 10 similar animations that done in 10 different ways. And that's a good thing about decompiling websites. You learn a lot of good and maybe not so good practices. Yeah, so I needed to use the texture, and then to use the texture I actually need UVs. And last time when we used UVs on that Matthias Biabiani website, we actually calculated them. And what I learned here is you can actually cut this corner as well. So I actually had something like this. So my coordinates are running between those numbers. What are those numbers? Like between these numbers. So like minus half of this number, plus half of this number, and then minus half of this number, and plus half of this number. So to calculate the UVs, I would need to do something like this. I would need to have same numbers, then divide them by the, no, not, this is the whole size of the, like, minus half plus half, like I just said. So I need to divide the actual position with this number to get something between minus 0.5 plus 0.5. Yeah, and for this I will need the varying v position. And to do this, I'm gonna v position set position. So now I have v position. If I just preview v position, I'm gonna see something interesting. No, not this time. Oh yeah, because I have this error here. Yeah, so if I just preview them and you see those colors, they kind of like UVs, but not like UVs because those numbers are way too big. So we need to normalize them. So I'm gonna take the XY and divide this by this number. Did I have any error here? What? Line 99. Oh yeah, just the dot missing. Yes, now it's kind of somewhat like UVs, but we still need to convert it to the 101 range. Now it's like UVs, it's perfect. But when I did that, I actually realized, so the way I just cut the corners with the plane geometry to implement the positioning of each particle on my screen, just the same way, this plane buffer geometry, it actually has an attribute already. And if I just output this one, it actually has UVs already. Even normal, I don't care about normals, but still it has UVs. So I don't actually need to do anything because this geometry, even though it's particles, it's not plane anymore. It has the correct attribute for each of the vertices. So I could just do these UV varying, and then I could use it in fragment shader. So instead of new UV, I could just use VUV, and it's the same. So you don't need to make any hard-coded calculations for that. You could just do the UVs that plane buffer geometry. I know it's kind of obvious, it might seem simple, but I just realized that. And I could have done that in that previous stream too. It would be way simpler, maybe not to calculate those UVs again, not to normalize them. All right, so now we just have this, and now I could use the texture. So I could do the TT because it's double texture. And why it's double? Because I just said so, yeah. And then we could use T and yeah, TT because T is already taken. And then use VUV and then just output this. So yeah, we actually just have this thing, but in a particle way. So it's not an image anymore, it's just the particles, and it's just simple as that. We really haven't even used any calculations, shader stuff, just we actually don't even need the V position anymore. I just have this UV. This is so easy. Okay, and then I need to make some distortions for my image. First of all, I need to change the background. And then let's do some distortions. So these are already particles here. If you just zoom, it's gonna be looking cool. It could actually be a video as well. I could just use a video on those particles, and that might be the way to simplify the actually to avoid those start and end images they've been using. But let's start with the distortions. To make distortions, I'm gonna bring back my settings UI here. So we have some settings at least. Now I need to have the curl animation. I'm gonna just copy paste the curl noise. I believe it's just the usual curl noise. You might even avoid using it. It's the open source version. If you just look for curl noise GLSL, you'll find one of the variations of this one. Doesn't really matter. They are all gonna be looking beautiful if you put the right numbers in there. Okay, and now I kind of want to use this curl here. I'm gonna look at the chat real fast. Yeah, I had one stream with React 3 Fiber where I was creating some GIF, some looped GIF. All right, let's continue. So what I want next, I want to make some distortions on my images. Like I want to somehow distort it all. For that I would need to calculate the curl noise for each particle and use it as a time, right? So let's just start by calculating this noise. Curl noise actually returns me a three-dimensional vector like this. So I'm gonna start writing from the end. So the final position is gonna be position plus distortion. Then distortion is gonna be equal something out of curl noise. Yeah, because we have pretty big numbers over there, like minus 400, 800, we probably would need to divide or multiply with something small, all those numbers. But, I think we could just do like vector 3, it accepts vector 3, I guess, right? Yeah. And have here like position x. That would be 0. Distortion. And this distortion is going to be something, some function of the position. Let's see if it shows us something. Yeah, we kind of get in there. We'll probably need to multiply this distortion, so now the particles are distorted a bit, which is actually also kind of nice. But they're not moving really, right? So let's add time to one of the coordinates at least. So now they are living their life, they are partying, there no social distancing in there at all. But I want some social distance for my particles, so I think the time should be a bit slower on this one. Maybe I should just expand this. What I could do here to make them like bigger, to make them fill my whole screen, I could multiply this with the same position that I had actually, like, because I'm essentially adding something to each position of my particle. I could just multiply this. I believe the curl noise is returning me something between 0 and 1 or minus 1 and 1. So if I multiply this, it's going to be filling my whole screen. Like this. Yeah, it's starting to look beautiful, maybe. I believe I want it to be more white than like narrow, than more landscape than portrait orientation. And for that, I think I would need to multiply now this with the small values because it's too random. It's better now. Maybe it's too small. Just a bit bigger. Good morning, everyone. Yes, it's starting to look better. Maybe if I wanted to make it wider, I would just multiply and expand this. Well, z coordinate is 0 as essentially, so maybe I should just replace this with 1 so it makes sense, and then multiply this by 2. Yeah, I think it's getting there. Something like this, starting to look cool. It's still z coordinate is 0, but I believe I don't actually need z coordinate. All the animation could be done in 2 dimensions. Yeah, let's try to use time and micro noise. Okay, it's gotta be. It's gonna be something like this. Maybe let's switch back to the red particles for a moment so we could see them. Beautiful, isn't it? Maybe white would be better. Something like this, but we wouldn't be able to see them all because part of the video is actually black, so we couldn't be seeing the part of the video only. So what I wanted to do, I wanted to add the distortion value, and then here, and then have an option and then have a uniform here. And multiply this whole distortion thing with my okay, then the name should be a bit different, I guess. Distortion 1. Multiply this with distortion. And then I could just do this. Yeah. It's getting better. I believe I would need to add time here. It's gonna look better like this. And then maybe actually kind of random function you could add here and just experiment whether they would work or not. Let's see. Yeah, kind of getting that look, that vibe. Something is still missing though. Maybe this value should be smaller anyway. I think it's the animation that we have. Just that we have also black particles which are forcing us to. Let's discard all the black particles. What's that? Is it double ampersand in GLSL? Yes, now we got rid of some black particles and I think it's looking much better than before. But actually do it with the final color, so I don't get tied to the texture color. Yeah, looking good. All right, let's continue next. Yeah, of course it's possible. You just have the JLFrog color A or alpha and you can use it. Okay, let's continue next. Not only they have this distortion, they also have this lightning, like particles that just light it out. And I believe this is just the bloom. It just connects bloom. I'm gonna just copy paste code, include all the dependencies. Then I probably need to instantiate all this stuff. I think this is where it begins. Add post-processing. Now I should do lots of this. It's this, and now it's this settings. I believe I only need plumb strength, okay. 0 to 10. And then I need to set it. How do they set it, this bloom strength? I think this just, they go to the bloom pass, this bloom pass strength, yeah, like this. I will just set it in my request animation frame, so it's updated all the time. Okay, now I have a bloom strength. Everything seems to be converted. Still something is wrong. What? Oh yeah, we need to fix the imports because they are pointing to the wrong place. Examples. Should be fine. Now we have the bloom strength. Not really working anyway right now because we're still rendering the default canvas. To change that, we need to render the composer. We also need to set size of the composer. This is a common mistake I did. This composer set same width. And then I need to render in composer. So instead of my renderer, I'm gonna have this. I think it's starting to work, yeah. So now we have this bloom effect. Now if I do the distortion, I could just do this. And it's so cool. I like bloom. Everybody likes bloom. Game developers especially. Oh, you mean I can discard them based on the opacity? Ah, yeah, you're right. But there's one thing, there's one reason I wanted to discard them on the other way around, not only on opacity. Okay, so now we're kind of approaching this animation. I already have this. I think it's because the sRGB output rendering, if I just remove it. Yeah, the lights are better now because I don't need sRGB encoding when I'm using post-processing. So now lights are correct. So now we need two things. We have an image rendered with particles and we have a video. And I need to connect those two things. Maybe I also need the end image of this sequence. So I need somehow to combine the video and the particles. Well, there's also some insight that I learned here. So the stream essentially is about insights. Let's replace particles first with the red, with something red. Yeah, it's also kind of nice thing which I just did. So we have this red square. How do I connect this red square with something from the DOM? Because the video they're using, it's just the usual HTML5 video right there. Because they have the canvas, but then they just have the usual kind of video that is playing on the background. And then they connect this video with the WebGL animation. They just fade out the video and then start the WebGL animation. How do they connect the sizing of the video and the WebGL animation? That's what I wanted to share with you. Kind of nice trick. It's so simple, it's you're gonna be surprised. It's a CSS trick. It's a CSS trick to connect WebGL and HTML. So if I have some video, like the video, what the hell? Have some video, and actually I would put this video there. So the video is gonna be 1 MP4, right? And then I'm gonna make it absolute. Let's see if we have it here. So now we have the video. Okay, I'm gonna make itself like half transparent. And I'm gonna add the border. So now we see the video. So how do I merge the HTML and WebGL in here? Oh yeah, it's gonna be so simple. So first of all, I'm gonna center. because obviously my particles are centered on my screen. Then I need to just center. Okay, the video is now centered. It's kind of big for now. And well, actually the only difference at the moment, they're both centered, but one is bigger than the other. So to fix that, I could just do this. I could do come on. I also need to oh yeah, because the video is not being scaled yet, I need to do this also. Yes, now we have this red border is the HTML video, and then the other one is the is the WebGL video. To connect those, I will do, I think I need to have this one smaller than the other. I believe I've been multiplying them by 1.5 somewhere here. So maybe I could just guess the number. Just do something like this. Kind of. So if I know the HTML number now, they are, I think they are right now. Maybe sort of this. Yeah. Because I have this red border, it just distorts a bit all these colors. But anyway, what we have right now, we have the video on top of the WebGL, and they have the same size. And the cool part about this, if we just scale it, it's gonna be always the same, because right now the WebGL canvas and the camera, they are more like height dependent. So depending on the height of the screen, the size of the object will change. And the same goes for my video DOM block, because it also depends on the size, on the height of the viewport. And this means that I don't actually need to put any resize functions in JavaScript even. They're just at the same spot all the time. However I scale it, it's just on the same spot. So it's just the simplest trick how you can combine the HTML and WebGL. Right there. Pretty simple, pretty stupid, but it works. And actually the guys used exactly the same trick on their website. So when we see the video, it's just the video that has the, well, let's just see it. It's the video that positioned as a, see, they even have the same numbers. Well, obviously, because I'm decompiling this website at the moment. They though have this weird thing. I think they didn't want it to be real centered, and that's why they made it a bit to the bottom, to the top. And I believe they made the same offset inside the WebGL too. Well, that works. That's beautiful. Okay, so let's just do a simple dump test animation, like how we could now animate this whole stuff, how this could actually work. Okay. So I'm gonna, where do I start? So I'm gonna start with playing the video, and then the video would explode, and then it would come back to the next video. That's what I'm gonna do. I'm gonna do this simple animation. And then the next video starts playing. I'm not gonna do the full loop, so just this one sequence. So let's do it. Let's see how the GSub can help us do this. Downsides of use video texture. Actually, didn't know. I should have tried to use video texture. That might actually simplify things a lot in here. Seems like a good alternative. All right. I'm glad you guys found your mistakes. I made them too. Even not once. Okay, so I'm gonna start with playing the video. I need to remove the opacity first. I need to make it autoplay. How do you make autoplay, right? Yes, now it's playing. I will remove the border. I need to get rid of the border. Okay, just for a moment, let's remove autoplay. Now I need to change scale a bit, just so they really fit in. I know it shouldn't be like that. You probably could calculate those numbers anyway. Mm. Yeah, I think this is the best that I could get. Like this. Programming. Yeah. Yeah, I think it is. So now if I just remove the opacity from my video, like opacity, and if I get back my image, well, there's a real minor jump. I think it wouldn't be even noticeable in the animation. So when I switch the video to WebGL now, you can hardly notice that. Okay, so first of all, I'm playing the video. And I need to have event of the video. So this here, this video. Video 1. I have the video playing now. I need the end frame of the video. This is the end frame. So we don't actually see the end frame at first, but it's there behind the behind the video curtain. Yeah, it's just there behind. So now the video stops, and on end video JS on ended. I think it's ended video. That works. Right, so right when it ends, I already have the gsub. I have the gsub. This is the old syntax. So now I have the gsub. I could just do so at the end, I think I should. Oh, okay, I need to. At the end, I should be seeing the particles already. So when the video ends, yeah, not seeing the particles yet. Why? Uh, Yeah, those are already particles, and you could hardly see this switch because the video is playing, and the video is kind of dynamic. So video is not playing anymore for me. And why is that? Well, I could just force it to play. What's wrong? Oh, I need to have this interaction. So I need to play the video actually. Okay. Not a problem. Not a problem. Oh, maybe just mute it would help. Maybe it's because of the muted. Yeah. Because the browser thinks that I might have an audio in my video and you can't really play any audio automatic, so that's why you need. So now at the end are the particles. So when we actually did this animation, I would need to start animating things in my shader now. Yeah. All right, thank you. Yeah, everybody knows that. Everybody knows that. Just forgot about that. It somehow played before that. I don't know, a couple of times it just played for me and then it stopped playing. All right. Why would it play in the first place? I need to do the animation. Okay, so then just sub 2. I need to animate the move a bit down, so I already have all the objects. So I need to animate distortion now. And distortion is this material this material uniforms distortion, and then let's say 1 second, maybe 2 seconds. 2 seconds, so it will be easier seen, and value I think 3 is good. Then I would essentially need to do the same back. And let's see if it works for us. Something is wrong. Maybe because I'm still setting these settings, like this distortion in here, and it's been overwritten all this time. Yes, now we have kind of a video that explodes into an image. Now we need to add the bloom part. So right when I'm exploding the image, I'm gonna also do the bloom thing. I believe the easing would also make it a bit better. So it's gonna be this bloom pass, and then I'm changing the strength to what? 10? Say 10, and then right back. Okay, I believe I'm also alright in this same variable. Bloom pass didn't work for some reason. This bloom pass strength. Why though? Why do you think it didn't work? On the second one? Yeah, you're right. Thank you. Should have created the timeline actually. It would be easier with the timeline, just one after another, but now it's way too big, I guess. We need to add some easings here. The delay is 2 here, so delay should be fine now, right? So I think I would use power 2 in out. How do I write that? Like this. And the same for the distortion back. I think so, maybe just a bit smaller strength. Now it's all about playing with numbers and getting some kind of look with those numbers. Right, it's too bright for some reason. Maybe I need to do the easing here as well. This one's gotta be in, and this one should be out. Yeah, it was just about the easing because they started to be bright too early in the animation and it didn't look cool. Okay, so now we have this. I could also just loop this whole animation. Just let's loop it with one video. Of course, it's possible to loop a couple of videos, but I think I could see a way how we could do this with one asset. It's gonna be T1. Okay, it's gonna be T1. Then I'll have the second texture in my material. It's gonna be T1. T1, and then fragment shader. I have the progress, okay, and I have the T1. And then I could use this to mix two textures probably and get back to the original texture, to the starting texture. Or should I? Yeah, while it animates, I should get back to the starting texture and then start the video again. Okay, so for final texture, same thing. And now here, not TT, but the final texture, this. And now I need this line because if I have two different textures and some of the textures is black on the same pixel and some picture is not black on the same pixel, then I would need to hide those pixels and show them only when they have color. That's why I need this line. Okay, final texture. So I need to animate the progress in the end. So while I do this whole animation, I need to animate the progress at some point. Let's do that. So while it's all bright, I'm gonna just animate the texture back. Okay. This should probably do the trick. So I'm animating the progress of my uniforms to the 1 somewhere in the center of my whole animation. So in the end, I should see again the starting image of my video. which I'm not seeing. Okay. Because why? Yeah, should have used the timeline. What the hell? We're almost there. So duration delay value 1. This material uniform progress 1. I'm not overwriting progress anywhere, so this should have worked. So it kind of works when the progress is right, so it's uniform. Maybe I mistyped something. Progress 1 actually working for me. It's gotta work. It should work. So it's starting all right. But then the final image somehow is the final image. Even though I should have this material uniforms progress value set to 1. Yeah, let's just output let's just debug this thing real fast. Okay. Attribute property value of undefined. Do I have progress? I don't have progress. That's what. I think I just overwrote it with some other variable. That was the reason this whole time. Yeah. Okay. Progress. Let's delay this one. And now let's get back to the video. Yeah, and then we could start the video again. So right when we end the last animation, like when the bloom pass got back, we could just do this video. And fade it in again with this. Oh, this is very dirty GSAP code. Yeah, it works. It's perfect. Yeah, we need to fix the second iteration, obviously. And of course, this code could be much cleaner than that. But yeah, this transition just works for us. And then the video starts. And this is how you do this animation on the Memtrust website. Oof. I think I gotta try to make it with just the video texture. It might be just enough to use 2 video textures and just animate between those 2 video textures in the middle of the whole animation. And then we could avoid all those screenshots and make this animation even better. But why would we need that? I think we pretty much learned like what we had to learn from this animation. So like a couple of tricks like combining HTML and DOM, using UVs from the Three.js generated geometries. Yeah, it's kind of cool. It's not that complicated, but it looks amazing. Surely it looks amazing. Yeah, that's what I wanted to show you today. Also share it on Twitter that I was participating in a huge team of like I'm really honored to be part of it. I really just did a small part in that, but the result is pretty amazing. I'm talking about the volumetric content streaming. It's actually pretty cool. It's actually working on my PC too. And as a bonus content, if you just made it to the 1-hour live coding video of a sleepy developer with a minor headache, I would show you how the volumetric content streaming actually works in my real-time browser. So this is a video, you might not believe it, right? But if we just go to Rackwas's player, let's just see for a moment how far the technologies has came. And again, there's a huge team, and I'm really honored that they trusted me to do some coding with this. So you could see my PC is now, well, it should be struggling. My fans are out because I'm streaming right now and I'm sending my video to the YouTube, but we could still see this nice 3D animation, and you could just look from any angle, really any angle. And this is just, it just amazes me how far the technology has come. You could watch the concerts with that or do anything with that actually. And she looks pretty nice. I mean, not in terms of the human, but in terms of the texture. Yep. So yeah, guys, that was it. Thank you for spending the morning with me. I hope you liked this video, this small decompilation of this Japanese amazing website merged with video and CSS and HTML and DOM, because I really like the Japanese aesthetic. Yeah. If you like that, just like the video. If you didn't dislike the video, I'm always open to any suggestions, like what I can improve, what I could do better. I'm still planning to do short videos. Since I was planning this one to be short, but it's over 1 hour. Anyway. Yeah, of course I have the project link in description. I don't usually share the code anyway, but the link to the original website of course be shared, so you could preview and you could just follow my steps and do all the stuff, because it's just simple as that. Yeah. Thank you guys. Everything else in comments. I'm gonna stop streaming right now. So see you on Twitter and comments, and probably next Sunday, if I'm gonna be still alive. Optimistic. Have a fantastic day, guys.